begin with, I'd like to focus and welcome our team from Melbourne University, and they were responsible for the Integrated Design Studios. I want to introduce you who will be leading the presentation today, Brendon McNiven, who's the Enterprise Professor from the School of Architectural Engineering, yes it is something, from the University of Melbourne. Also throughout, who's been part of that journey has been Professor Lu Ai from the Energy Engineering section of Melbourne University, and Dominik Holzer, who's the Associate Professor in Architecture from Melbourne University. Now they haven't done it all, trust me, they've had other people involved, but they have been responsible for our integrated design studios. So Brendon, the floor is yours.
Thanks very much, Tony. As Tony said, my name's Brendon McNiven. I'm an Enterprise Professor in Architectural Engineering. There's no question it is a thing. Melbourne Uni, we're lucky to work with QUT and University of Wollongong, with Wendy and Georgios and a whole host of other people underneath them, so it was very much a joint effort. It's been a fantastic 2.5, 3 years of exploration, and it's been very much about trying to marry architecture and engineering along with client requirements into much better technically performing buildings, and we've learnt a lot along the way. That's the same slide Tony just presented, so that's why we're all here. It is a big issue, there's big gains to be made, and this has been in the back of everyone's minds right from the start. So the studios were done across 3 institutions in environments looking pretty much like that. At Melbourne Uni it was 16 students, a mix of architects and engineers, a studio leader overseeing them, a client involved, so we tried to get real projects, the closer to a real project the better, plus consultants, so architectural consultants, engineering consultants, and also some specialists along the way. And what we basically did was to take the theory that was out there on integrated design, and there's a lot of theory on integrated design, it does get done just sporadically, and we tried to test that in practice and learn lessons on how we can actually make that work, and we learnt a lot along the way. We had 14 different studios across the 3 institutions, 8 different building typologies, produced a whole lot of material, and the ones to concentrate on there are those last 2. There's a catalyst for integrated design, which is really a recipe book. How do you implement integrated design on projects? And there's the carbon catalogue. So as well as learning about integrated design, because we were looking at case study buildings in different building typologies, we ended up being able to map the net zero design moves, if you like, across the different building typologies. So that's really a first start on best practice for net zero design in those different types of buildings. And that's really the underlying potential that's out there. So the green lines there is the renewable part, so that was one of our arena's real interests. The light green part is the consumption reduction, which is really taking what you've got and just doing it better through integrated design. And then there's excess generation, which is in the colour, which is disappeared on the projector colouring, but it's off to the left there. So schools and ambulance stations, for instance, are totally possible for net zero. Running down to the other extreme, which is data centres, not so easy. But that's really underwritten a lot of the material that's been produced from it. And so, having said that, I'm going to pass it over to Dominik Holzer, who will take you through some of the details of the studios. Yep.
What did the percentages mean on the right-hand side? Over 100%.
So, just because one of these unfortunately the colour for excess generation has disappeared. So what we do is we start with a use. We then have a consumption reduction. So we actually design better to take down, energy requirements that were up here, come down to here, and then we supplement that with generation. So photovoltaics, whatever else, brings it down even further, and then. In cases, we don't get all the way down, and so you have residual grid consumption, which are the orange lines there. And so in cases, that excess generation is so large, in the cases of schools, you could actually produce 3 times the amount of power that they actually need just through photovoltaic. So it's essentially coming back from the 100% right the way back to 221% on the other side. Does that make sense? Okay.
Thanks, Brendon. Glad to be here. I will give you a more in-depth sort of introduction to those various studios that we've run, and I've also invited Wendy Miller from KUT and Georgios Kokogiannakis, did I pronounce it correctly, from University of Wollongong to join me as well to talk about some of the work that they have done. Look, going through this material, it was quite a major effort over 2.5 years. We came up with the sort of what we call the carbon catalog. It is not a comprehensive catalog, as you will see. It's a snapshot of certain potential, like of exemplars actually, where we can see what the potential of different active and passive measures are for carbon reduction. Each of them going through a process that I will describe in a moment. So first of all, the IHAB teams, as we described, were across 3 universities, 14 projects, that was already mentioned. We had over typically a semester, at least Melbourne Uni would be 12 to 14 weeks, slight variation with the other institutions, but there was a good sort of semester or term duration where we examined novel technologies, where we worked with emerging practitioners, students, of course. We worked with consultants, industry consultants. We worked with a client on these projects, and really important to have the blend between architecture, engineering students, construction management in some cases involved as well. And every project that was then undertaken, or every studio, I should say, there were several projects then selected, and via the engineering industry consultant, there was a feasibility vetting done from, and I think some people who were involved in this vetting are actually in the room today, which is great to see. So there was this feasibility vetting undertaken to look at these options a bit more in greater detail and look at the zero carbon potential. Now what you will see today is really a consolidation of the various projects that were undertaken. As part of that, we identified 3 categories. The first one was what we call the simple one, was in our case it was schools and an ambulance station. We had the more complex projects with aged care, mixed use, and a community center. And then we had what we call the specialist projects with data center, aquatic center, transport building, and a lab. Really important, as I said earlier, we are not claiming that this is a sector-wide detailed catalog of all these types. We understand that the projects that we've run were in different climate zones. We understand that there will clearly be variations. And Wendy will particularly talk about, for instance, with mixed use, you have so many different types of mixed uses, so you can't really nail it down to one typology as such. But clearly we were aiming to understand some of the key logic, if you want, behind what initiatives and what measures could be taken. Just here, quickly described again, those 3 categories. Simple construction function requirements, no significant plant or equipment that consumes a significant quantity of energy, and so forth. Obviously, with the more complex ones, there was always a question of how high is the building, how many stories versus how much roof space do we have for PV systems, and the specialist projects being quite particular in their own sort of setup, very frequently high energy demand that's in there. So how do you deal with these types of projects? In addition, these are some of the key sort of aspects that we were looking at. We were looking at energy use, energy source, embodied carbon, and overall holistic sustainability. So we're working with many of the students were also working with the broader side to understand what do we do with waste, with water, other natural sort of planting and so forth. So really understanding how net zero energy, how the design of these facilities in these contexts, how that impacts on the net zero opportunities. Also in terms of what we've been measuring and pathways, we looked at, of course, and this was described earlier by Brendon, the business as usual operational energy consumption. We looked at energy use intensity for any specific location. We then looked for integrated intervention, including passive strategies and active service technologies and on-site renewable energy generation. really important. And just from my experience, if you deal with emerging practitioners, if you deal with students, it's very difficult for them when they come from an architecture background to get their head around these benchmarks or even these sort of the context. So one clear message that we got, that we had to be very careful in how we set up these studios, how we generated the project briefs, how we involved the client, how we then curated the integrated design process and had strong leaders who would remind students that we looked into, and of course also the industry practitioners, we didn't look into a classic sort of designer and consultant relationship. We really looked into co-design, where there was a what would you call it, bidirectional sort of influencing and understanding and development of ideas towards zero carbon. And zero carbon was really the perfect vehicle, you could call it, for us to interrogate or investigate integrated design, because it's such an overarching topic that affects everyone. So clearly the estimate of energy use intensity reduction from passive design and active service technologies, as Brendon explained before. Yep. Some of them retrofit, some of them new. So that will be shown when we go into more details on those projects. And of course, the potential for on-site renewable energy generation was one of the key elements as well, with, I would say, solar PV being the predominant factor that we looked into. Again, obviously we looked into carbon dioxide equivalent, we looked into the kilowatt hours per year, but then per square meter gross floor area. In some instances, I believe some of the investigators also looked into per person or per bed, is that correct? Per bed, yeah. And because that, for like hospitals, for instance, that would be, or aged care in some instances, would be the kind of key factor to measure there. And this is where I'm going to take you through those different typologies in a bit more detail. Whoa, that would be quick for me to finish off. You don't want me to finish off yet, do you? Good. So in this case with the schools, they were in the ACT, and this was a refurbishment. So we had 4 different school projects altogether. We had 2 studios with 2 projects each, and that was all retrofit. Clearly, ACT having its own very specific climate, so I'm again mentioning that if we had a project in northern Queensland, it probably would look quite different, but some of the base principles would still apply. Overall, we found that the energy use intensity was roughly around 100 kilowatt hours per square meter per year. In some instances less, in some instances more. Use reduction, what we could understand, there was a potential of about 60% in use reduction, and obviously a massive potential in developing renewable sort of energy, having extra supply via the solar PVs. You can see some of the approaches, just to let you know. So we had, of course, the students look into their design process, looking at the site, understanding the site from an energy perspective, which is something that, again, for architecture students was something relatively new. They were not exposed to that idea before. The architecture students would look into the site mostly from a geometrical, from a traffic, from a connectivity perspective. But some students had to learn about a solar path, sort of understand what impact that has on the site. Some students had to understand how other, like again, the existing nature, trees and so forth, had an impact, and they looked into the building envelope and tried to understand what are currently the characteristics of the existing, in this case, building envelope. So some of the key initiatives that were investigated, both passive and active, were efficient lighting, heat recovery, ventilation, passive house standard air tightness, and definitely the rooftop solar PV systems that we found were absolutely crucial to help us with that generation here. So I believe that overall, client was very happy. Client was involved throughout both semesters where the school projects were run. Got lots of interesting feedback, of course, from ACT schools being government-led client, and lots of feedback that was generated for government in this regard, that hopefully will make its way into future policies and so forth. The next one were, sorry, just before I go to the next one, just a few examples of some of the designs. So we gave students clearly some liberty also to explore how to change the facade, how to change elements within the building, how to change the roof, how to look at natural ventilation, look at different sort of glazing options, and then the PV solar, as I mentioned earlier, being a pretty major sort of energy generator as well on site. The next one in the simple project category is where the ambulance stations. So again, very simple buildings as such, so not really complicated. Typically single story, if not double story in some instances. Business as usual energy consumption. I think we estimated that for roughly 100 kilowatt hours per square meter per year. We managed to look at a energy use reduction about 50% with the initiatives suggested by the students and supported by industry consultants, but also, again, via solar PV, quite an opportunity to generate energy on site, renewable energy on site. And a lot of the technologies that we were investigating were actually market ready. So there was clearly a bit of a push for innovation as well. Sometimes we found it's more about how you combine market ready technology instead of coming up with something completely new. We'd also have to admit that students have a certain understanding about these issues, and it was a massive learning curve for them. But certainly with the support of the consultants collaborating, we were certainly able to push the envelope on a number of issues. Again, high performance building fabric, enhanced air tightness, passive solar design, as well as rooftop solar systems were some of the key technologies that were investigated. And you can see the results in the graph and some of the more sort of graphic representation of what these projects ended up looking like. And again, what you can see here, and what I believe as an educator, what I'm really proud of, is how you start to sensitize students towards looking into design in different ways. We should not forget, in a traditional way that architecture students are being taught, they don't necessarily give the most attention necessarily to these environmental issues. And they might be bombarded with functional requirements for, in this case, an ambulance station, might be looking into some level of human comfort, but that's typically where it stops. And by using the integrated design studios as a vehicle to investigate carbon net zero, there is clearly a way for them to rethink how they look into their layouts. So looking at airflow, for instance, looking at opportunities for daylight and air tightness of facades. That's something that was relatively new to most of them. And as much as they struggled with it in the first, let's say, third of the semester, once they realized what was possible and once the collaboration was there with engineering students and the consultants and clear pushback also from clients sometimes, which is great to have in these sort of environments, there were some really tangible outcomes and I think some massive learning for them that resulted in that. So here's just a summary. I'm not going to read them out. Of some of for the simple typology, some of the interventions and measures that worked for these contexts. I think we both had, for the ambulance stations and possibly also for the schools, we had batteries also. That quite a number of teams were suggesting battery use as well in conjunction with the PV systems. And yeah, I believe I did mention ground source heat pumps, heat recovery, ventilation. So there's quite a number of measures that were investigated by the various projects. If I then go to the sort of the more complex projects, I'm going to start off with aged care. Again, here quite a spread depending on the size of the project and project type and which type of aged care. But we see somewhere between 100 and 230 kilowatt hours per square meter per year. And there's a large variance in the energy use intensity here. But again, you can see the potential. I think there was about 40%. We should have that here. Yeah, 40% reduction in energy use. And via the use of solar PV, we could offset a further 20% from the business as usual. So quite substantial sort of changes that are possible and quite substantial savings or reduction in energy use on these sort of building typologies. Some of the things that were suggested were, again, passive design features, heat recovery ventilation, maximizing solar PV. And the problem clearly is once you get to the type of aged care facilities where you have sort of hospital level equipment and multi-story, there's clearly then a limit in how far you can really talk about net zero to be achieved in these, but you can see that there's quite a reduction that's possible for these typologies that we experienced. Some examples of what students came up with, you can see that here, and I think I blended together some of, is it Wollongong and Melbourne? I think there's some examples here of how these sort of, again, about the outcomes. And again, really proud of the fact that we had students then very actively interrogating building facade and how different mechanical systems would interact and how, holistically speaking, how the performance could be affected by these different passive and active interventions. At this point, I would like to hand over to Wendy from QUT, who will take us through the mixed-use typology and some of the findings from there. Thank you. That's the...
Yeah, great. Thanks. So the two studios that QUT ran were both, we had a client who developed land and owned and operated buildings, and these buildings had to include an element of senior living as well as be mixed use. So, and that mixed use could be whatever the teams decided were appropriate to the case. What we found is that mixed use as a typology is very difficult to get to net zero for a range of reasons. First being that there's no baseline energy consumption to compare it with, because it really depends on what are the specific uses of the building and how do you get all that together and what parts are included. There are different classification systems as well of a building. So the Building Codes Board, so the National Construction Code has classes of buildings, but other mechanisms classify buildings in different ways economically as well. Building functions can change over time, and even within one class of a building, let's say class 9C or class 5 as office buildings, whatever, the energy use intensity can vary greatly depending on where that building is. And then different asset owners also calculate energy use differently. So one asset owner of a university, for example, might classify energy use intensity only by the teaching space and not all the other spaces within a university. And the same with aged care centres. And different spaces can be used for different purposes over time. So if you had a traditional residential aged care facility that has doctors' rooms and a gym, for example, for only the use of the occupants, that's a class 9C building. But the moment that that gym or those offices are open to the general public, it then becomes also class 9B and class 5 buildings, which then put in a whole lot of different fire rating, access and egress requirements, etc. And some spaces may need to be classified differently depending on when and where they're being used. So and there's no clear methodology for allocating the energy consumption. And an additional thing is mixed-use buildings that then have residential component as well present a further complexity because it becomes a home as well as a workplace, and that then presents HVAC challenges regarding what type of system, what comfort level, who gets to decide, who gets to control, and all of those issues. So there are issues regarding mixed-use buildings. So this slide, I just want to present a few things regarding the mixed-use buildings that were proposed for a greenfield development in Caboolture. So this is subtropical region. And some of the initiatives focus particularly on the energy envelope, natural ventilation, passive cooling. So this is just north of Brisbane in the subtropics. But the table on the right is showing some of the technologies and the potential reduction, not reduction from a business as usual, but reduction from certain perspectives. So vertical green systems, for example, so whether that's your green facades or internal green gardens, can reduce in subtropical climates the cooling load of a building by 20 to 44%, and that's been shown by research around the world. What that means in terms of total site energy use hasn't been calculated, but it's reducing the cooling load. you can see a number of other things were looked at as well, so PVs and an emerging energy storage system, so a battery system with supercapacitor. A local Brisbane company starting to produce those things, so what the potential is for that case. And another important thing showing, I guess, the teams of those, of this particular design studio was looking at the value of parametric design, where you can say, what is the optimal, what are the different building material characteristics that will give me the lowest kilowatt cooling per square metre, and you can say I want to explore these 5 different glazing ratios, these different insulation ratios, etc. And a lot of design teams in industry don't actually use the power of parametric modelling to actually determine what is the best insulation, glazing, etc. And then for a tropical zone, so this is for a project in Cairns again, some of the solutions that were proposed, so in the middle there is a secondary roof. This is a solution that you do see in other tropical areas. So the secondary roof above a standard building can reduce the cooling load by around 16%. If you reduce the cooling load in the tropical region to a maximum of 50 kilowatts per square metre, it then actually makes hydronic cooling system a technical feasibility, and then a hydronic cooling system uses 80% less energy and less cost than running a chilled water system or a variable refrigerant system, and that was verified by one of our consultants. We also looked at the impact of energy policies, for example, for a building that has residents as well as non-residential areas. If the policy relates to the same as for detached houses, in that you can have 5 kilowatt peak PVs per household, as opposed to what the small scale renewable energy size limit of 100 kilowatts is. And the other one there is the increase in PV output. If you actually combine green roofs with PVs, can actually increase the output of PVs by 2 to 8%. The one that's not shown there is a feasibility report that came in last night that showed that if you reduce the energy load by having a super insulated building, you can, at a site level, put in a PV system that can provide all of the electricity required for the daytime loads, and the excess solar energy during the daytime can be used to run a hydrogen system to store the energy to then convert that into the nighttime loads. So showing 100% feasibility for a whole site in Cairns using super energy efficient envelope plus PV plus hydrogen.
Thanks, Wendy. Georgios, do you want to jump up and give us maybe 2 minutes or 3 max?
2 minutes, okay. Yeah, I can do that. All right, so I'm just going to talk about one of our design studios. It's the last retrofit, I guess, of the IDSs. This is a building in Wollongong. Do I press this one?
Green one, yeah, big room, yeah. Oh, no, where's back?
Yeah.
Big room, yeah.
So this is an existing building in Wollongong, a community centre, about 4,500 square meters. The upper floor is a library. The lower floor is separate community spaces, really, that they're renting out. The client was Wollongong City Council. In this case, defining the business as usual number that we were required to define was easy because we had historical electricity bills. So that was about 200 kilowatt hours per square meter per year in this case. Very consistent up until 2017. Then they installed, they covered the largest part of the roof with PV panels, and that dropped to about 150 kilowatt hours per square meter per year. Then our project investigated other options on how to reduce that even further. And then through typical solutions, passive design solutions, and green roofs and green facades and so on, it was possible to reduce that down to 120 kilowatt hours per square meter per year. And there was not a lot of flexibility with changing the internal layout because it was an existing building. There were not as many options as with those other design studios that you saw earlier. Changing the external facade was an option, an expensive option, but we didn't have a lot of options for the internal layout. So 120 kilowatt hours per year, then we investigated different solutions, adding additional generation of PV, covering like carports at the parking space will further reduce the energy used to about 90 kilowatt hours per square meter per year. So being an existing building gave us less options, but there was still a lot to go from the 150 kilowatt hours down to 90 kilowatt hours. Simulation models were developed, as you can see here, energy simulation models. The suggested solutions, you have the traditional shading elements. The client was very willing to also look into smart lighting, some low-hanging fruit solutions that are missing currently from those buildings. Heat recovery ventilation and new filters and maintenance issues were also identified that could offer some extra savings there. And again, if you start using, depending on the size of the PV panels, if you start using your carport and the available surrounding areas, you can reduce that energy use even further. That's all.
Fantastic.
Yeah,
Thanks.
thank you.
In the interest of time, and given that we have, of course, other iHub partners also still presenting, I'm going to fly through the next few slides. I'm not going to go through the summary. We've heard that aquatic centers, we saw a lot of potential to use the large roofs of those centers for PV panels to have pretty large supply opportunities there. Again, I'm not going to go through the details. 30% energy use reduction, and so forth. So some of the examples just shown here of some of the student outcomes. Laboratories or labs, we did one for CSRO. Again, roughly, let me see, 18% reduction, and with the other sort of initiatives, looking at further 30% with energy offset. Some of the examples here, quite some wild architecture, as you could say, I could see, but again, students starting to think differently of how to approach these kind of projects. And you might have some crazy geometry, but you can still, of course, consider the environment as part of that. And our current computer technology allows us to do simulation on pretty much any shape, really. The one that is probably standing out most are the data centers, and we have to admit defeat on this one here. There was net zero was not quite possible. We came very close. 1% reduction, yeah, didn't quite cut it, but just the enormous energy use of these facilities made it impossible for us to get anywhere close to net zero, and despite sometimes larger areas, just really not possible. What we then looked into, and this is where I just want to show some of the examples, was how could we then still look at the different way of how data centers are designed. Maybe they do become something more than just a black box somewhere where you have opportunities for looking at using the massive excess heat for greenhouses or for swimming, like public recreation centers where the heat for the water comes from the data center. But yeah, as I said, in terms of a zero carbon objective, that wasn't quite met, we admit, on this particular project. I'm going to hand back to Brendon. I'm not going to go through those summaries. We have seen that summary slide already, so I'm going to hand back to Brendon to talk about the catalyst and some of the way we translate some of the findings from academia also into practice.
Thanks, Dominik. Yes, so that first part, the carbon catalogue, was the net zero level of exploration, and this is what was behind it. It's how do you actually make integrated design happen, and there's a few areas you need to concentrate on. The client project team is very important. Having clients in the studios was was a real plus. We hadn't realised it at the start, but getting a direct connection between designers and client is really important, and that just gets diluted through industry. And not that project managers don't do a good job, I'm sure, on lots of different fronts, but the more people in that communication string, the less easy it is to get direct requirements from the client translated through to the buildings. Project planning and procurement, starting as you mean to go on, setting up project culture, and then right back to the specifics when you're actually designing. You can see at the back there, there's a long list of small points. It's quite a detailed report. There's a lot of information in there. I'm just going to go through maybe the top two lessons in all of those different things to give you a bit of a taste for it. Client project team. One of the lessons we had was people want to do this stuff, right? Clients and designers and everyone you speak to, they want to do good things for the environment and they want better design. But to make it up in a client team, you need someone who's serious about good design as a firm or as an organisation. You need passionate individuals, and you need those individuals working in an environment where they're empowered to make change. A lot of the clients, project managers, feel a bit constrained, and that's just a recipe for disaster. They've got to have some elbow room to move and actually change the way that we do things from just doing what we've always done before. Procurement is a big thing. So QUT in particular looked at this sort of thing. So there's models out there. Integrated project delivery model out of the States is really good. It's essentially alliance contracting with mandated BIM. But again, it's very different to the models we have, The procurement and traditional models we have now almost fight against integrated design. So there's a mindset change there to happen. And you've got to be clear about your briefing. You've got to be setting out to do integrated design and just make it very clear from the start. Culture setting. You've got to actually get people to understand that it isn't business as usual. We're in a new design environment now. We're going to do things differently, and we're going to achieve something really special out of it. We need to set common goals and incentives, so everybody's got to be on the same page and understand what we're actually aiming for, and you've got to really constantly revisit those goals and incentives to make sure that you're in the right direction. And lastly, the process specifics. COVID gave us the chance to explore working remotely versus working face-to-face, and I, for one, was really amazed at the difference in that process. The designers in the face-to-face studio had a much better time, a much deeper experience, and produced, I think, probably better results than the studios that were forced to run totally remotely. So there's no substitute for sitting across the table from someone and having deep communication that's back and forward very, very quickly and has all of the nuances of the physical world. And multiple disciplines, and that includes clients and all sorts of other stakeholders at the table at the same time. Everybody has something to actually offer, and that co-author mindset is really important. This is something, enterprise professor means I come from industry, and the company I worked for, it was a thing, how do you actually integrate architecture and engineering? You get to 50% just by talking to the other person, and you'd be surprised at how many people just don't talk. Architects will just shoot off a set of drawings and say, make this work, right? That's not talking to each other. So talking to each other, you can accomplish a lot. You can coordinate, and we call this empathetic design. You really get the value when you start to understand what the other does, and importantly, value that. So once you get architects that actually understand a bit about the engineering and value that engineering, they're willing to actually bring it on board and give up some of their stuff. And the same with engineers. Once engineers understand how valuable architecture is to a building, and it is valuable, they're willing to actually get on board and create something really good. So that 80% is where the whole becomes greater than the sum of the parts. And the last 20% is really just how well you do it. Some people are naturals at it and do it very well. Other people struggle a bit. So I'll just leave you with that slide there. They're the two really big ticket items that we see coming out of this, and these will be available on the website in the reporting. 27th of May has been seared into all of our our minds, so the catalyst for how you do integrated design and that net zero carbon catalogue that Dominik took you through. And I should say, we were very fortunate to have a lot of industry partners jump on board, contribute a lot of personal time and a lot of time in kind from the organisation. So thank you to all of those people. I think I've even given you a spare minute, I think, Tony.
Very good. Probably a couple of things that came out of that. One, and there'll be a chance for doing some questions and answers as well with our panel. The other thing is, if you notice, that we've also been able to do an integrated design, work with other universities, other members of the iHub to be able to do various projects. I think that's very important in that space. A couple of things just before we're on. Brendon talked about the partners. There was an overarching steering committee that was part of this, and they're an external steering committee that looked at all the projects, vetted the projects, prodded as we went along, and I do want to actually officially mention them. Many are here today, many are also online, and they were in no particular order. Troy Wilson, Luke Menzel, Nathan Groenhout, Phil Cowling, Simon Humphreys, Peter Henke and Kristen Simons. A number of them could not come, believe it or not, because they're under the iHub, sorry, not the iHub, the COVID protocol. Could be iHub protocol. And also two other people that made a significant impact to all of these projects. One was Vince Ahern, who has program managed the whole situation, and Sammy Zeng, who looked after the finances, billing, chasing, and all the other legal requirements that need to go along that. So the significant number of people in there, and I want to thank them very much for the work that they've done.